Hello everyone, myself Himani Sharma from RPIIT campus. In today's class, I discuss about the dropping mercury electrode. Dropping mercury electrode is consist of a mercury reservoir from which mercury drops comes down as a small drop through a capillary. It is generally act as the cathode. It is known as the indicator electrode or the microelectrode. The height of the mercury reservoir is adjusted to set the drop time, that is the 1 to 5 second. Drop time is the time required to form the every fresh drop of mercury from the capillary. Inside the tubing, wire contact is made where the mercury flow through. The anode consists of the mercury pool at the bottom of reservoir, which act as the reference electrode, and its area is large so that it is not polarized. Both anode and the cathode are connected across the appropriate end of the battery. The applied voltage can be changed by adjusting the sliding contact along the potentiometer wire EF. There are the dropping mercury electrode. Mercury drops from a small capillary. Mercury pool acts as the anode and the supporting analyte. Solution analyte is the working is the mercury electrode is the polarizable electrode. A large change in the potential. The change in the potential energy equals the gain in the kinetic energy, which can be used to find the speed upon passage of small current. Second, can be act as the both anode and the cathode, but generally used as the cathode. The pool of mercury act as the counter electrode, that is anode, if DMF is cathode. A pool of mercury due to the large surface area has the low current density, and the non-polarizable therefore has the constant potential. Examples is the consider the polarography cell containing a solution of the cadmium chloride to which the external EMF is applied. Second, to analyte solution, cadmium supporting the electrolyte like KCl is added 50 to 100 times of the sample concentration to eliminate the migration current, additional current produced by electrostatic attractions of cathode. There are cation to surface of a dropping electrode, an unpredictable and undesirable effect to be avoided during analytical voltmeter. Pure nitrogen or hydrogen gases bubble to expel out the dissolved oxygen. The positively charged ion, cadmium present in solution, will attract the dropping mercury electrode by an electrical force and by the diffusive force resulting from the concentration gradient formed at the surface of the electrode. Thus, the total current flowing through the cells may be regarded as the sum of electrical and diffusive forces. When the applied voltage is increased and the current is recorded, a graph will be obtained. In today's class, I discuss about dropping mercury electrode, construction and their working. Thank you. Hello everyone, myself Himani Sharma from RPIIT campus. In today's class, I discuss about the alcovic equations that is come in polarography. Alcovic equation is a reaction used in the polarography relating the diffusion current and the concentration of the non-polarizable electrode, that is the substance reduced or oxidized at the dropping mercury electrode, polarizable electrode. The equation for the current is the 607 ND half Cm 2 by 3 T 1 by 6, where ID is the diffusion current in the micro amperes, and 607 is the constant of various numerical factor including the Faraday constant and density of Hg etc. N is equal to the number of electron duly involved in electrode reaction, and D is equal to the diffusion coefficient in the centimeter square second inverse. C is equal to the concentration in the m mole per liter, and m is equal to the weight of Hg following via the capillary, and there are the mg share their seconds inverse, and t is equal to drop time in the second. The Alcovic equation is the hold the good for the drop time to vary between 2 to 8 seconds. In order to accomplish this aim and objective, the following two critical adjustments may be done carefully. First is the length of the capillary, measuring the Hg pressure to bring the drop time very much within the range, that is 2 to 8 seconds. There are the four major governing factors that influence the Alcovic equations. First, both m and t shall change with the dimension of capillary, its length, and the applied pressure of Hg resistance, the reservoir to form the drop. Second is height of Hg column must be maintained constantly, as the drop time slowly depend upon the applied pressure by the column of Hg at the tip of DME and analyte solutions interface. Third is the applied voltage in a DME assembly is responsible for causing the possible changes occurring in the prevailing surface tension of a drop at the tip of electrode. Evidently, the variations in temperatures and viscosity must be at bare minimum level because it disturbs the diffusion coefficient most significantly. In today's class, I discuss about the following Alcovic equations for the polarography, diffusion, current estimation. Thank you.